All right, guys, welcome back. Here is question 7. It was on financial mathematics. Now let's have a look at 7.1. It says that John invests an amount of money in an account paying an interest of 15% compounded monthly. Calculate the annual effective interest. Right, so we know the formulas. 7.1, we know the formula that joins nominal interest and effective interest. So let's go 1 plus, here is our formula here, and then this is the effective interest. It's equals to 1 plus nominal interest all over n to the power of n. So therefore we can substitute here. We are looking for this one, effective interest is equals to 1 plus, and then therefore 15 all over the set compounded monthly, which is equals to 12, then it will be to the power of 12 here. So therefore we are looking for this one, for the effective one here. So it's just going to be 1 plus, then we're just going to plug this into our calculator so that we can find out how much this is. All right, so effective interest, therefore we can put this in bracket, therefore multiply by 100 to take it to 2%. So initially on my calculator I'm getting this number here, and then if I were to multiply this by 100, it is going to give us an effective interest of 16.08%. Right, great stuff. And that's how you would deal with 7.1. So 7.2 says 7.2 says here, Tino invest, keyword invest, 500,000 in an account earning entry interest of 6% quarterly. So this is gonna be 4. Tino decided to withdraw 11. Okay, keyword here, withdrawal, keyword withdrawal. So he decided to withdraw 11,250 at the end of every 3 months. Okay, Tino will continue making this regular withdrawal until there is no money into the account. So how many withdrawals will he make if he was to withdraw 11,250 from this investment? So keyword there, it's investment. So investment, you know that they are withdrawing, so which means you are going to use a present value formula, which will give us 500,000, and then these regular withdrawals, they are almost the same as regular deposit as you would deal with them. So therefore this will be like a regular withdrawals, same as regular payment. We have got our 6% here divided by 4 because we are doing it quarterly. So we're gonna go to our present formula here, which is stated that every regular withdrawal 1 minus 1 plus I, therefore in brackets to the power of minus I. So basically here you are looking for n, guys, because now they are asking you the number of withdrawal. This is more like if it was future value, is going to be the number of payments that you need to make. Look at me there, not writing the question mark properly. Okay, so divided by I, so we're gonna have 500,000 here on this side is equal to all over 11,200 close bracket minus 1 plus 0.06% over 4 to the power of minus n, because we are looking for n right there. Excuse me. So n 0.06, we need to divide by 4 because now in this case is compounded quarterly. So therefore we are going to cross multiply here with that. So 500,000 here, are just simplifying, guys, simple algebra. 500 1000, 0.06, cross multiply. Therefore, we also divide by 11,250 is equal to, okay, so now here we're going to have 1. Then I can simplify what is inside the bracket. Here is going to be minus, which is giving me 1,015, all close minus 1 close bracket right there. So therefore, if you punch this into a calculator, guys, let me know what you get on the comment section. I'm getting 2/3, which is equal to that. Therefore, what I can do in this case is to take 1 to the other side, right? Okay, so we're gonna have 1 minus 1,015 minus that. Okay, so instead I would take this to that side, then take this to that side. Okay, just to make it a little bit positive, but whichever way is gonna work, guys. This is just algebra 1, or then minus that to the power of negative n is equals to 1 minus 2 all over 3. So now with this, you can come here and say, what do I need? I need 1 or 0, 1, 5, all this just to find the value of n, guys. 1 over 3 is our answer. So what we can do in this case, we can log both sides. You can say log this side. You are going to have log 1,015 to the power of negative n is equals to log 1,3. In this case, then you can bring the negative down, as in is like an exponent 1. I feel like this is a lot of work. It's worth 5 marks, so it is worth it. Divide by log 1,015. Therefore, on this side also divided by log 1,015. Therefore, our answer would therefore be negative n is equal to negative 73,7887. So divide by negative 1, divide by negative 1. Therefore, our answer would be approximately 73 withdrawals. Right. So this person would make, Tina would have to make 73 withdrawals. Right. And that will be your answer for 7.2. Let me know what you guys think. We needed to calculate the value of n. Now let's move on to 7.3. 7.3, interesting question indeed here, but basically I went through this several times, just trying to see if what I'm doing is correct. So I'm here with confidence that what we're doing is correct. So here what we have, it says here on the 1st of March 2021, Abby made a once-off deposit of 12,000 into an account earning an interest of 9.5 compounded monthly. Right. So first, this is our first statement up until this point, and then she said she deposited 500 into the same account on the 1st of April continuously, keyword here, continuously, into then making deposit of 500 on the first day of each month thereof. Right, great stuff. So now it says here, calculate how much money was in the account immediately after the deposit of 500 is made on the 1st of March 2025, exactly 4 years after the initial deposit. 6 marks. Right. So now in this case, guys, what they did, if they speak about an investment, if we speak about keyword here, it's what they are saying there about the investment. If a person invests money compounded monthly with an interest with once-off deposit, so it means now we are referring to this formula. All right, guys, please make sure that you do watch a video on my channel that is a lesson on mathematics that is showing you the keywords that they use. Then you would know which formula to use. So now this is a once-off deposit that they did, that Abby did at 12,000. 1 plus the interest of 0.095 divided by 12, because it's compounded monthly. So remember now, for how many years? For 4 years. Because why? This money will stay in the account the entire time, right? So let's just get the answer there. Punch into my calculator. I'm getting 17,521.15. right? Great stuff. Now for the second part of their question, it says here, remember now, this person is making what? Is making deposit. So maybe if I were to describe this on a timeline, it would look something like this. This is March 2021, and then therefore this is March 2023. Okay, so this is March 2023. So this is March 2025. So now it means now this person, Abby, it's making increment payment. So increment payments, when you make a frequent deposit, so continuous payment each and every month. So April is somewhere here, we deposit 500, and then we go throughout the year. 2024 start somewhere here, put another 500. 2025 somewhere here, put another 500. So this increments payment simply means what? Future value. Well done if you said future value. So now this is basically what it means. So future value increment payments, that's what you do. Then you're gonna make one payment, 1 plus I to the power of number of payments minus 1, close bracket, all over I. Great stuff. So 500, we deposit it incrementally, plus at an interest of, is the very same interest, 0.095 all over 12, right? Okay, here's another bracket there, 12, but for how many years now? Okay, think about this very carefully. This person started Abby started doing this on April 2023. So 2023 to 2025, in between there is just 2 years, right? So this money, these 500s, all of them would stay in the account for 2 years. So therefore you close bracket, all over 0.095 divided by 12. So the future value here in this case will therefore be, if I were to calculate this correctly, 13,158,65. So now the total amount into the account will therefore be the sum of these 2 here. So how much money will be in the account? So this will be the amount that will be in the account there, 21.8. You just add the two together. Guys, there's many ways to kill a cat. You could have done this differently. You could have done this together all at once, not a problem, as long as we get to the same answer. So my final answer in this case for this equation, or for this question, will be 3676,83. Let me know what you guys think of this question, question 7. Let me see you on the next upload, where we will be doing question 8, which is on derivative, or is on calculus, first principle, and derivative thereof. I will see you on the next upload.